Hello class and welcome to Unit 10 Video 2. Today we're going to go ahead and look at logarithms and logarithmic functions. Your learning targets are that you can evaluate logarithmic expressions, you can solve log equations and inequalities. Okay, so let's look at some graphs. So consider the graph of y equals 2 to the x and its inverse. Okay, so 2 to the x is the blue graph listed on the grid below. So here is 2 to the x. And its inverse. Remember, inverses always go across that line y equals x. Okay, so they always are symmetric across that line. Okay, so the red line is its inverse. Since exponential functions are 1 to 1, the inverse of y equals 2 to the x is also a function. Okay, so what that means is if we had our parabola, and we do the inverse of that, it would look something like this, going across that line. Okay, would this be a function? No, it would not. Okay, so to be 1 to 1, you have to pass your horizontal line test. So to be a 1 to 1 function, which means only one y for every x, you'd only be able to touch one point at a time. So this one fails the horizontal line test, which means it is not a 1 to 1 function. Still a function, but it's not 1 to 1. Okay, so that means its inverse needs to be adjusted a little bit. So this one we typically know the inverse of x squared is the square root of x, and so it only looks like this piece. Okay, so that's what its inverse would look like. Recall that you can graph the inverse of a function by switching x and y. So if you took all these points and swapped them around, so if I had 0, 1, now I have 1, 0. If I have 2, 4, now I have 4, 2, I could get this equation. Okay, the biggest thing to know is that yesterday we talked about exponentials, so this one is our exponential. And when you go across it, the inverse of an exponential is a logarithmic function. So it's a logarithm. Okay, so logs undo exponentials and vice versa. Just like multiplying and dividing. They undo each other. Adding and subtracting undo each other. So here are our functions. So we did exponentials yesterday. Today we're going to go ahead and look at logs, which are the inverses of exponentials, so they undo each other. Okay, so logs are probably new to you. So what are logarithms? So logs with base b. Okay, what it means is it's the inverse of y equals b to the x. So if you switch x and y around, here is what a log would look like. So y is called a logarithm of x. Okay. Basically, the way they write it, though, is y, which is our logarithm, equals log base b, so notice how my base b, to the x. Okay. So this is our exponent. This is our base, and x is our answer. Okay. So there is that. So let's look at an example. It says write each equation in exponential form. So here's what I recommend. You take, and this was really your base. So raise to this exponent. Okay, so it's 8 to the 0 equals your answer, which is 1. Is it true that 8 to the 0 equals 1? Yes. So this is my answer. That's not written very nicely, though. I'm going to change this. 0. Anything to the 0 power is 1. So just remember, this was your base. This is your exponent. And then the 1 is your answer. Okay, so that is how you would write that in exponential form. B, okay, same idea. What I always recommend is it's always this base, the little guy. Take it and you swing over to the other side. So it's 2 to the negative 4th equals our answer, 1 over 16. Is that true? Yeah, because just remember our rules of exponents. I can rewrite this as 1 over 2 to the 4th, which is 1 over 16. But this would be my answer in exponential form. And let's look at C. We would take our base, which is 4, raised to our exponent. So it's 4 to the second, so 4 squared equals 16. Is that true? Yes. Okay, so there it is in exponential form. Now we're going to go the opposite way. We are going to go into logarithmic form. Okay, so A, we have 10 to the third equals 1,000. Okay, so it's log base. Okay, so log, my base is 10 of 1,000 equals 3. Okay, so I'm just putting it back into log form. B, I'm going to pull C out right away. So there's B. So same thing, it's log base. We are saying it's base 9. Log base 9 of 3 equals the exponent, equals 1/2. Okay. And this one, it'd be log base 125 of 5 is equal to the exponent. Okay. So there is writing it into log form, so going backwards. Now we're going to use those rules to evaluate each logarithmic expression. So A, it's log base 2 of 64 to the y. So I'd have 2 to the y equals 64. All right, well, we need to figure this out. I'm not really sure. I know 2 to the third is 8. 2 to the fourth is 16. Let's try 2 to the fifth. 32, so 2 to the 6 must be 64. So what does y equal? Y equals 6. All right, so let's look at the next one. Okay, this one is 3 to the y. 3 to the y equals 81. Okay, so 3 to the third is 27, so I would try 3 to the fourth. Does that give me 81? So it's kind of a guessing game. Try and make an educated guess, but 3 to the fourth is 81, so y equals 4. 4b. And let's move on to C. If we rewrite it, it is 4 to the y equals 256. 4 to the third is 64. Yes, so we would try 4 to the fourth, which is 256. So y equals 4. All right, so logarithmic functions, some things we need to note about. Okay, logarithmic functions have the following properties. The function is continuous and one-to-one. So remember, exponentials were continuous and one-to-one. Continuous means you do not have to pick up your pencil. Okay, the domain is the set of all positive real numbers. Okay, so positive real. So that means that x is greater than 0. That's my domain. If I were to draw my log function, this is going to be an asymptote. Remember on my exponentials, the x-axis was an asymptote, so this is my asymptote. And the range is a set of all real numbers, so that means range is all real. And it always contains the point 1, 0. So it looks like this. Okay, so there it is. My domain is all reals. I will never go past 0, so that's why x is greater than 0. And my range is all reals. It's going to go all the way down and all the way up, slowly going up, but that's what it is. Okay, so log's one of the harder ones to remember what it looks like, but you should know what a log function looks like. And this is what it looks like. Y equals log base b of x, where b is greater than 0 and b does not equal 1. Okay, so there is that. So let's look at number 4. It says solve the logarithmic equations. It would be 4 to the 5 over 2 equals n. Okay, so remember our rules of exponents. If it's like this, it's really the square root of 4 to the 5th equals n. So the square root of 4, I don't know why I wrote 2, but that's what it is. Square root of 4 is 2. 2 to the 5th is 32. If you're ever not sure and you want to just check your answer, you can type it in. It'd be 4 to the, and if your calculator doesn't go up in the little exponent like mine does, you would have to actually put parentheses around this fraction, which gives me 32. So there it is, just to double check my answer. Here is B. It's log base 9 of x equals 3 over 2. So it would be 9 to the 3 over 2. So I'm going to try and do it by hand again. So it's really the square root of 9 to the third. The square root of 9 is 3. 3 to the third is 27. Okay, so let's just check. Is that the correct answer? It is 9 to the 3 divided by 2. Does that give me 27? Yes, it does. So there is my answer. All right, C. This one's a little different, looks like. So I'd have b to the second. B to the second equals 121. Okay, so in order to do it, I would take the square root. So b is equal to, remember when I take the square root, always to answer plus or minus. The square root of 121 is 11. However, my rule is that my base has to be greater than 0. B has to be greater than 0. So my only answer that I would actually write down would be 11. All right. So that's a little solving. Now we're going to move into our learning target on how to solve logarithmic inequalities. All right. So if b is greater than 1 and x is greater than 0, okay, log base b of x is greater than y, then x is greater than b to the y. All right, so that would be one value. And if we have log base b of x is less than y, okay, then it's going to be in between 0 and b to the y. Okay. The reason that we need to include 0 on this one is because can b be less than 0? No. Okay, so we have to put the restriction that it's in between 0 and whatever that value is. Okay, so if it is greater, which this one is, okay, to solve it, it would be x is greater than 2 to the third. Okay, well, x is greater than 2 to the third, well, that's going to mean that x is greater than 8. If I did it the other way, it would be, you would flip the sign. X is less than negative 2 to the third. Well, x is less than, that would be negative 8. Is that in our domain? No, it is not. So we do not need to include it. You only need to include x is greater than 8 because this piece is not in our domain. Okay, when it is a less than, it's always going to be a compound inequality. Okay, because your two answers that you would get would be x is less than x to the fifth. And remember, we said you can't have your domain, your x cannot be less than 0. So that's why we have to include the 0. So 0 is less than x is less than 3 to the fifth. Okay, so greater than, there's only one piece. Less than, there is the 0. You have to include it. Okay, remember, it's always good to be greater than a bigger positive number, but you can never be 0. Okay, so this one is a less than. So I'd have 5 to the second. So x is less than 5 to the second. Okay, but my domain, remember, is x is greater than 0. So that means I have to include my domain. So I would have 0 is less than x is less than 25. So less than cannot be less than 0, so you have to include the 0 on that one. All right, here's b. It's a greater than. So you'd have 4 to the third. So x is greater than 4 to the third. And so x is greater than 64. Remember, domain is x is greater than 0. Is 64 greater than 0? Yes, that's why I do not have to include 0 on that one. And C, we would have x is less than 2 to the fourth. So I would have to include 0, my domain. And 2 to the fourth is 16. So there is my answer for C. Okay. Example 6, few more logarithmic equations to solve. Biggest thing to notice is that if you have log of 5 and log of 5, whatever's on the inside has to equal each other. So you'd have x squared minus 2x equals x. They have to equal each other. Then I would just solve this as is. They are quadratic, so I would have x squared minus x minus 2 equals 0. And then I would go ahead and factor. What multiplies to negative 2 but adds to negative 1? Negative 2 times 1. So I would solve. Now I look at my answers, okay? Remember, whoops, this is negative 1. Your domain is x is greater than 0. Is negative 1 greater than 0? No, so I cannot write that one down. I would just write down x is equal to 2. Okay. Moving on to b. We have log base 3, so that means what's on the inside is equal to each other. So I would have x squared minus 15 is equal to 2x. I notice once again quadratic. So I'm moving everything to the left-hand side. And I factor what multiplies to negative 15 but adds to negative 2. 3 and 5. So 3 and 5. For the 2 to be negative, it has to be negative 5, positive 3. Then I would solve x plus 3 equals 0, so x equals negative 3. X minus 5 equals 0, so x equals 5. Domain, once again, is that x has to be greater than 0. So when I plug them in, this would make it negative, which doesn't work, so my answer is x equals 5. And our last problem, we have log base 14 on both sides. So once again, I can set what's on the inside equal to each other. So I would have x squared minus 30 equals x. I notice an x squared, so it's a quadratic. Move it all over. Factor, so it multiplies to negative 30 but adds to negative 1. 6 times 5, for them to add, this would have to be negative, positive. And once again, when you plug it in, you can't have a negative, so x equals 6 is my final answer. All right, that is it for Unit 10. Practice 2. If you have any questions, please write them down, come and ask. Otherwise, have a wonderful day.